In the previous video, I introduced you to the idea of the mole and how we use the mole to help us relate ratios within a balanced equation and understanding that different atoms weigh different amounts. So when we weigh a gram of something, it actually may be a different number of atoms for different substances. And what I wanted to introduce you to in this video is how we use the idea of the mole to help us understand those relationships and how we do what is called a molar conversion. You see, when we dealt with the mole, you may have noticed that the units were grams per mole, literally the number of grams per 1 mole of that substance. Well, that sets up what we can use as a ratio. And we can use that ratio to do all sorts of calculations to help us understand the amounts of substances that we're dealing with. So let's take a look at some examples, and this is the first one we're going to work through, is what is the mass of 2.00 moles of carbon? So what we want to do is look at, okay, I was given information in moles, and I want to turn it into mass, and mass is measured in grams. So how am I going to go about solving this? Well, I always like to say start with what you know. You know that you have 2.00 moles of carbon. And I would highly recommend write out the units, write out the symbol for the substance, and yes, I don't know why the abbreviation for mole is literally just mole with no E, but that's what we use. So now what we want to do is convert this into grams. So we need to use a ratio, and we need to know how many grams there are in a mole of carbon. Well, luckily we know from the periodic table. A mole of carbon is 12.01 grams per 1 mole. That's the molar mass. You may have remembered that I wrote this previously this way. Those mean the same thing. It's just over 1 mole because 1 mole is 12.01 grams. So what I'm going to use is this ratio to help me figure out how many grams are in 2.00 moles of carbon. So I am going to do a multiplication by this ratio, and we need to make sure we set up the ratio so the units are in the proper spot. So I want to be able to cancel out moles and be left with grams. And so what that means is I need to divide by moles and multiply by grams. And so in carbon, there is 12.01 grams for every 1 mole of carbon. And what ends up happening here is moles of carbon cancel. And all I have is 2.00 multiplied by 12.01 divided by 1. My answer here is 24.02 grams of carbon. Now, if we wanted to round this to significant figures, I have 3 significant figures. So I would have 24.0 grams of carbon. And that is my final answer. So really all we're doing is converting. We're using a conversion to go from grams to moles or moles to grams and be able to use that to help us understand the amounts of things that are being related in a chemical reaction. Now, that's how we go from moles to grams, but I'm going to show you now an example of how we can go from grams to moles. So let's take a look and see what we have. How many moles are in 3.00 grams of O2? Well, this is what we're starting with, and we want to find the number of moles. That is what we are trying to solve. So again, start with the information that you know. I know that I have 3.00 grams of O2. And we are going to want to convert this. So I need another time sign dividing line. And what we need to think about now is what is my ratio here? Well, my ratio is going to have to do with O2. And keep in mind, our ratio when we're dealing from grams to moles is going to be the molar mass. That's the only one that actually has both grams and moles. So then what is the molar mass of O2? It's going to be 32.00. So how did I get that? Well, there are two oxygens. That's an O, by the way. And each oxygen has a molar mass of 16.00. That means that the molar mass for O2 has to be 2 times that. You see, because there are 2 atoms of oxygen in a molecule of O2, the molar mass is twice that of a single atom. So now again, think about how we want to set this ratio up. We have 32.00 grams per mole, which is the same as writing 32.00 grams divided by 1 mole. But what we can do with this is actually use this either way, with moles on the top or grams on the, with moles on the bottom or grams on the bottom. It doesn't really matter. We just have to make sure we choose the right direction when we're doing this calculation. Since I want to find moles, I am going to put moles of O2 on the top of this division line. And I want to get rid of grams of O2, so grams of O2 is going to go on the bottom. And now you just need to make sure you keep the numbers with the correct units. There is 32.00 grams for every 1 mole of O2. So what's going to happen is grams are going to cancel, and you are going to get your final answer. And our final answer here is going to be 0.0938. Our units are going to be moles. And if you wanted to write the substance, it's moles of O2. And so this is how we do what's called a molar conversion. How do we convert from a gram of something into a mole of that thing? Doing a molar conversion is one of the really important skills when it comes to higher level chemistry, and it's something that you do so regularly that you often don't even think about it. And so it becomes, again, one of those things that's really important to practice. So what you're going to find is lots of examples and lots of work. Make sure you go through it and check how you're doing. And if you have any questions, please make sure you ask, and I'll be more than happy to help you out. Thanks for watching, and I'll see you next time.